We're supposed to make a function to model this graph. Just sine and cosine can model the same graph with just like a phase shift. So just look at what Newton is asking for here. They want us to adjust it to be y equals something in terms of cosine. So we got this general structure. Oh, plus d. I ran out of room. Let's start with A. Well, actually, let's start with the midline. That's probably makes the most sense. The midline is the y equals equation that makes a horizontal line through your trig function. And if you look, you can kind of eyeball it. It looks like it's 2. But to be sure that it's 2, check out the high and check out the low. The highest point is 3, the lowest point is 1, so the midline is 2. So that's going to be our D. I'm going to go ahead and plug that in right here. What else we got going on? A. I guess we're kind of ready to talk about A. So cosine of x looks like this. So that's my x and y grid. It's pretty bad looking. Cosine starts at the peak of the amplitude because think about cosine of 0. It makes 1, right? And then by the time you've gone 2 pi, you're back to the start. So cosine starts at the peak. We can make cosine start at the bottom by multiplying the outside by -1. That now if you do x equals 0, cosine of 0 is 1, so you've got -1. It starts at the bottom. Wait, that's kind of a bad graph. That's better. Okay, so that makes that switch. The reason why I mentioned that is so that when you're trying to picture these graphs, sometimes you might need negative cosine. And actually, we need it in this graph because look, if you just shift yourself pi over 3 units backwards, then it's the cosine. Then it's starting. It's like we've shifted our origin. So cosine usually starts at like it's either the top or the bottom, right? So if we shift it back pi over 3 units, then we'll be able to say that's a cosine graph. Okay. Trying to think of a better way to explain that. Let me make that graph a little bit bigger. Here's negative cosine of x. Starts at -1, right? And then it rises and falls. So we don't start at the bottom on the y-axis, right? It's not starting here and then it rises and falls. It's actually shifted a little bit. There's two ways of thinking it. You could say it's shifted back pi over 3 units, or you could say it was shifted forward pi over 6 units. They're both going to do the same thing, okay? And you should be able, like Newton should be able to accept either one of those answers. So you could say like if we just shift this back pi over 6 units to the left, then the graph looks like this, right? Then it starts at x equals 0. It starts on the y-axis. So the big point here is that we'll talk about A in just a second. The phase shift can either be C equals negative pi over 6, or C can be pi over 3. Either one can get you the correct answer. Because if you let C be negative pi over 3, that shifts us up to this place here. Negative pi over 6, that shifts us up. Let's go with the pi over 3 answer. So we've got this. Y has to equal -1. Cosine, we don't know what B is yet. We'll talk about that in just a second. And then the phase shift that we decided on was pi over 3. And now you might be questioning the positive sign too, like why is that a plus? The reason why this is a plus in between is because everything's kind of reversed in our heads. Like if you plug in negative pi over 3 plus plus pi over 3 makes 0, and 0 times b makes 0, and then cosine of 0 is 1, and then 1 times -1 makes -1. -1 plus 2 gives us 1. It makes this dot happen. Okay, so whatever you do, you can always go right back to the points that you have available, plug them in, and make sure it's still matching with what you got going on with the graph. Okay. Yeah, now I guess the last thing to do is to figure out what B is. B is the period. That is not correct. B helps you with calculating the period. B is not exactly the period. I said that incorrectly. And I think that's like something stuck in my brain from when I first learned this. You know how sometimes you learn something the wrong way and it's hard to get it unstuck? When I was in pre-calculus, there was one time where B and the period were the same, and it, is that even possible? Yeah, it probably is. Well, either way, I used to think b was the period. B is something that helps you calculate the period. This is the formula for the period. The period is how long it takes until the graph starts repeating itself. So if we go pi over 6 minus pi over 3, if we make this subtraction happen, it's 3 pi over 6, which is pi over 2, that's our period. Because that tells us the distance from here to here. Subtract 2 points, or subtract those 2 coordinates, and that'll tell you the distance between them. Okay, so the period is pi over 2. And now we can work on getting b by itself so we can plug it into the equation. So you can multiply b to both sides, get it out of the denominator, divide both sides by pi over 2, or in other words, multiply by 2 over pi. So you get 2 pi times 2 over pi, which is 4. So we just found out b is 4. And the other answer Newton should accept is y equals -1 cosine 4x minus pi over 6 plus 2. Okay, because that would still, the phase shift would, doing a minus pi over 6 would shift the original graph pi over 6 units to the right. So if you're having trouble understanding why things are working out the way that they are, please try plugging in some points and think about what happens. Right? As you're building the graph, think to yourself, like, if I plug in negative pi over 3, does it give me 1 for y? Or if I plug in pi over 6, does that give me 1 for y?